firing away. Christ, which one was that?
16.
Number 16. Take a look at 16 here. Problem number 16. There's a couple different ways to go about it, but this would be my recommendation to you. The first thing I would do is put together what variables I can put together on the top and the same thing on the bottom as my first step. So you've got a 6 up here. We won't deal with that yet. If you have an x to the negative 2 power and x to the 5th power, they get put together, Jeremy, to give me a x to the 3rd power, because you add exponents together. And then a y times a y is y squared. So the top kind of simplifies down to that. The bottom you can't put anything together, so now you're left with this. I'm going to change colors to make this smaller. And then you just have to cross off what you can. For example, 2 goes into 6 3 times. So the 6 and the 2 cross off to leave you a 3 on top. Okay, had it been flipped around and the 6 was on the bottom, the 3 would have been on the bottom. So just make sure you know that. Here you have x cubed, which is 3 x's. On the bottom you have just 2 x's. 2 of those 3 x's cross off, so you are left with an x. Maybe the book is wrong. And then on the bottom you have 1 y, and on the top you have 2 y's. So one of those 2 y's cross off at the bottom, so you end up with 3xy. Was the book was wrong on that? Yeah, I'll write it down here. So 3xy should be the answer for problem number 16. Same thing. Again, generally speaking, when you're given a choice, they put them in alphabetical order, so the x's would come before the y's. Emma Christ. Question on this one?
Yeah.
Which question?
How did you get from 6 to
3, because 2 goes into 6 3 times. Divide the bottom into the top.
Oh,
Cross cancel.
I subtract.
Nope.
I wonder if I can first.
Number 5, you said, Emma?
Oh, I didn't hear that.
Well, the answer to 5 was 50 miles per hour. Jackson?
How do you do number 13?
13. Yes, it's over here somewhere. 13. 5/12. Ladies and gentlemen, 5/12 doesn't appear anywhere on any of the sheets that I've given you. So what is your last case, worst scenario thing when you have to find or change a fraction into a decimal? Nobody likes to do it, but it is what it is, and you got to do what you got to do. What do you have to do, Jack?
Complicated division.
Well, it's not, I wouldn't call it complicated, but it's tougher than just a normal thing. Remember, any fraction is nothing more than a division problem. It is the top divided by the bottom. So the top being divided by the bottom. So you have to do this out, and this will get you the decimal that you will be able to change the decimal into a percent as well. So bring up your decimal. 12 doesn't go into 5, 12 goes into 54 times. You get 48, subtract. 12 goes into 20 once. 12 goes into 80 6 times. And you'll know that if you get an 8 again, you're just going to keep getting those 8, so it's going to go on forever. That's why you put the little line above the 6, because you just keep getting 80s divided by 6, 80s divided by 12. So this is your decimal. That would be the first thing you would find. Okay. Now to change a decimal to a percent, you just move the decimal 2 places to the right. So the answer is 41.6, but as a general rule, okay, you don't like to leave, especially repeating decimals in a percent thing. Well, 0.6 is what fraction? It's 2/3. So really we want this written as 41 2/3%. Okay? Because you can multiply or you can deal with this. You can't deal with this because it's a decimal that never ends. This one is more exact than that one. So that is kind of the gist of how that one would be. Problem number 13. Elsa? I can do number 12. And here would be the notes that I write to myself on problem number 12. First of all, it says, I'm going to have to go up to the thing up there. angle B measures 61 degrees. What is DAB? Someone go up to that problem up there. Angle B measures 61 degrees, and the question here is, what does this angle equal there? Well, if you look at your notes under parallelograms, did we talk specifically about parallelograms, right? I have this class right. Would somebody open up their notes for parallelograms? Because I believe two things we talked about with parallelograms were this. There were two facts that I believe I gave you with parallelograms. I believe one of them was that opposite angles were equal. Opposite angles are equal. I believe that was one of the things I gave you, right? Which means if B is 61 degrees, then B is 61 degrees. That doesn't really help me. But I believe I also told you that adjacent angles were what? Is that not in your notes, or is that a different class? Again, I get confused. Does it say who's got their parallelogram notes in there?
I don't know if I did it.
Somebody that takes some decent notes here. Come on, help me out here, people. Price? No. Does it say anywhere there? No. I just want to make sure that I didn't miss it. If I missed it, then not even something written there.
Jeez.
See, it must have been other ones. Maybe well, it is a transversal thing, but write this down then, since I probably missed it. First of all, on parallelograms, opposite angles are equal. Secondly, adjacent angles are supplementary, which means they have to equal 180 degrees. In other words, this angle and this angle here are two adjacent angles, as well as this one is adjacent to that. These two angles have to form a straight line, which means they have to equal 180 degrees. So you need to take 180 and subtract 61 from it, and you'll get your 119 degrees, which was the answer for that one.
It's in quadrilateral.
It's under quadrilaterals? Okay, maybe it's under quadrilaterals. Although it has to be, it's specifically the parallelograms, not all quadrilaterals would that be true for. So tomorrow, if they ask you that same question, remember opposite angles are equal and adjacent angles are supplementary. And you'll get that one right. Sage, you can run.
What's adjacent mean again?
Adjacent would mean share same side. See how this angle and this angle share the same side? You could call it next to each other. This angle's next to that angle next to that angle. And adjacent.
Wait, Sean, I'm so confused because did you get 119 because I was
Because I took 61 degrees away from 180. These two supplementary means they add up to 180 degrees. So 61 plus what number equals 180 degrees? And that's where you subtract the two angles. Nick?
For number 10, I got it right, but I just guessed.
Perfect. I love it when you guess. And maybe I don't know, maybe we missed the whole thing on parallelograms. Write this down. The area of a parallelogram, I'm going to have to look back and see. The area of a parallelogram is base times height. Okay. And the thing with base and height is that in order for something to be a base and something to be its height, they have to form right angles. So if you're asked to find the base and the height of a shape, the first thing you look for is that little square that the book will put when it's a right angle. And as I look, here's my little square. That means this number and this number are the base and the height. It doesn't matter that this line isn't even part of the thing, it's still the height. Okay. So the area is just going to be 10 times 7. Same thing with triangles, the base and the height. There has to be a square corner somewhere in order for you to do a formula that has base and height in it. So that's where I believe the 70 square inches came from in the whole spiel there. Maybe I was gone the day we talked parallelograms. We'll look back at it. It's kind of the same as S squares. Shellhammer.
How do you do number 1? I get confused.
El numero el uno. Number one is probably more an issue of semantics or you understanding where things go than anything. It is a percent problem, but it's not a sale problem. You're not increasing the price of something, you're splitting a bill into parts. And what parts are you splitting the bill into? You're splitting the total bill into parts plus labor equals the total. And then you've got percentages and you've got the actual dollar amounts. So I know that the $120 repair bill, that's the total of the bill. Of the $120, $36 were for parts. So what part was for labor? Well, I believe it'd be $84. Correct me if I'm wrong on that. Okay. You know that the total bill is 100%. And you want to know what percent was labor. So this is the one you need to know. You don't even need this part of the chart for this problem. And then it's just a matter of writing that out. X over 100 equals 84 over 120. And how do we do that part there, Jack? What's the best way to go about doing this little proportion, ratio, equal fraction, Gizmo Gadget?
Cross multiply and divide.
Cross multiply and divide. You could reduce if you want, that, you know, if you want to make your number simpler, cut this in half, it's 42 over 50. Oh wait, I could stop right there and say, oh look, 50 times 2 is 100, so 42 times 2 is 84. That ain't right. That's 60. That's because it's 60. See, I was just trying to see if you were watching. Cut 42 and a half, again you get 21, 60 and a half, you get 30. Here you go, you can cut 21, divide it by 3 and get 7, divide this by 3 and get 10. Now, 10 times 10 is 100, so 7 times 10 would be 70%. You can always cross multiply though, 100 times 84 divided by 120. That would be, I kind of like to, if I can do it an easier way, I think I'd like to do it too. Emma K. Rice.
For number 13, when you did it on the board, you got a different answer than the book. So I think.
Say it ain't so. Maybe the first mistake I've made probably since my last class. I did get a different answer?
Yeah, I think the book was wrong.
Maybe I read it wrong because I thought that's what I saw. Oh yeah, they inverted the numbers. I don't know what they did, but yeah, they in my book I have 14.6, but it should be 41.6. There's no way. Well, that's two mistakes they made on one lesson. Well, I don't always. It doesn't always end up that I give these same tests. Depends on what lesson I'm on, which test, because these go in lesson order. Yeah, so the book was wrong. This should be 416. The book had these two flipped and had .146, which would not be right. Nikki Tala.
I don't get number 15.
Number 15. Oh, I love number 15. I love it when they do these sort of problems here. I am going to box this up a little bit. Number 15. Now let's go through. I'll rewrite it just so I can see it. 40 plus 3 to the first. And everybody take a look up here because there's a number of things that I see people make mistakes on it. Point number 1, a lot of times people think anything to the 0 power is itself. That's not true. Anything to the 0 power is 1. Anything to the first power is itself. 2 times 2 for this one. And then sometimes get this as being 3, but it's 1 times 1 times 1, which is just 1. And if you made a mistake on any of those 3 different parts, you're not going to get the problem right. You need to make sure that you work from left to right here, even though in this one it doesn't matter. 3 plus 1 is 4. 4 plus 4 is 8. And then 8 minus 1 is 7. How many people made an error on one of these 4 things? So you got to be. You should always, when you see exponents of 0 and 1, in your mind you should say, oh, that gets a little tricky here, and actually I should really take my time to make sure I know what's going on with that one, because I see it so much between those two, and a lot of times 1 to whatever power people start multiplying. Lucas Espanol.
How do you do number 7?
I don't know. L L70. Solve and then graph the solution. These are solved just like equations, Lucas. So how do I get my letter x by itself?
Minus 2.
You just subtract 2. So now x is less than 1. And then to graph it, you just add the number 1. Is it an open circle or closed circle? It's open because it's not equal to. If there's a little equal there, it'd be closed. And then it's all numbers that are smaller than 1. It goes this direction. Again, noticing that the less than sign and that arrow point the same way. Problem number 8 while I'm there. Nathaniel?
Can you please do number 3? I screwed up on that. I don't know how.
One could only hope I can. Oh, number 3 is a good one to do. A vertical yardstick casts a shadow 24 inches. So you've got this yardstick stuck in the ground, casting in a 24-inch shadow. How tall is a yardstick there, Luke, or Nathaniel? Huh?
3 feet, I think.
Yeah, but since this is in inches, these dimensions have to be in the same unit of measurement. Since this is in inches, this needs to be in inches as well.
36.
Right. And then you've got a flagpole that casts a shadow too. We don't know what this is, but we do know that it casts a shadow 16 feet long. And these don't necessarily have to be in the same dimensions, but this and this will be in the end. So your answer is going to be in feet if you leave it that way. And then it's just a matter of you do the ratio of the small triangle to the big triangle. In other words, the vertical line on the small triangle over the horizontal line on the small triangle equals the vertical line on the big triangle over the vertical line on the, or the horizontal line on the big triangle. Okay, so it's just a matter of 36 over 24 equaling some number over 16. And again, you can do it any way you like. I would try to reduce these. What number goes into 36 and 24? 6. 12. If I do 12, I get what? 3 over 2. And then 2 times 8 is 16, so 3 times 8 is 24 feet. Grace?
Number 8, how do you get the formula for those?
Number 8, there's no real formula. You would just probably write in your notes that y equals mx plus b, where the letter m is the slope of the line, and the letter b is where it crosses the y-axis. And I'm going to guess that this is the x-axis and this is the y-axis. It's a little hard to tell. But this line crosses the y-axis right here. And what is y at that point? Y at that point is -1. Then in order to find the slope, you need to make a triangle out of what you can. Okay, you find 2 places where this line crosses both the x and the y line, and you make this triangle. And slope is always rise, how high it goes over run. So this triangle is 1 high, it is 2 wide, and it's going uphill, so it's a positive slope. So I put my 1/2 in for x, or in for the letter m, sorry. Y equals 1/2 x, and you just put the -1 or the -1 after that.
But I thought it was a plus.
What's that?
I said it was a plus.
Who said it was a +1?
Plus B on the.
Right, but the b can be negative. If it's a minus and a plus gives you a minus. Wherever it crosses, wherever it would be. So it's +1, it would have crossed right here on that same line. Shellhammer.
For that same one, can you just, instead of making a triangle, can't you just go up one and then close this?
Sure, that's the way you like to say it. But you're still making a triangle the way you're doing it. Jackson?
I don't understand how you got one.
Well, Jackson, let's look at the triangle again here. How high is this triangle? 1 unit high. How wide is it? 2 unit wide, 1 high, 2 wide. And then don't know what else goes in the code there. You make your triangle any size, it'll just come up that you'll have to reduce that fraction in the end. Jackson.
How do you do number 6?
That over here. On the top. What's the length of a diagonal of a rectangle that is 24 inches long and 10 inches wide? So you drew your rectangle, Jackson,
Yeah.
and you did it 24 by 10? 10 inches by 24 inches, and they want to know what the diagonal length is. So Jackson, what shape have I just created here? A triangle, not only a triangle, but a right triangle. And anytime I'm looking for diagonals and right triangles, I'm probably thinking the Pythagorean theorem. Okay, do I have a Pythagorean theorem that says 10 squared plus 24 squared equals something squared? Is there a 1024 up here? There is not. Right, but then you check to see if this is a ratio or proportional to something. You know, you cut them both in half, divide them both by 2, you end up with a 5 and a 12. Is there a 5-12 triangle up there? You know, 5-12. The other one needs to be 13, but you have to be careful with that because the answer is not 13. Since you divided by 2 to get the right proportion on that, you have to go back and multiply by 2 to get what it should be in the actual thing. So it's actually 26. 26 inches would be the diagonal. It's a 10, 24, 26 triangle. Okay, feel free to write those things down. Whew. Time for a glass of water, which I don't apparently have anymore. When does that happen? Every time I walk somewhere. Rockwell!
I have a question on number 6. My dad had me do 100 squared plus 24 squared.
You can do
Then
it.
I square rooted that.
Well, you square, you made this 100.
Yeah,
24 times 24 was what?
576.
576. You added those together and got 676, and then you had to take the square root of that,
Which is 26.
which is 23.
It's 23.
Oh, it's 26. No, it's 26. Yeah, it's 26.
What?
But again, that's kind of taken the long way because you should always try to recognize if it's one of these triples here.
Okay.
Emma Haynes.
So if that problem would always be one of
I'm going to guess the book is going to be nice and usually give you a triple. Otherwise, it's not going to work out evenly and you'll get some. If they don't tell you to round to the nearest whole number, then it's probably going to work out nicely. Because otherwise, you'll get some number that isn't a perfect square root, and you'll have to just like trial and error get close to whatever it would be. So I'm going to say yes. As a general rule, they're going to be nice and give you all triples there. Jack.
For number 9, can you explain to me how you got 1/4? Because I multiplied 1/6 by 1/2 together and got 1/2. Isn't that how we do it?
It would be if it asked you for a certain number on that number cube, but it said a number, an even number. So on your number cube, an even number is a 2, a 4, or a 6. So you have a 3 out of the 6 sides are numbers you can get, and 1 out of the 2 for the coin. So when you multiply that together, it's actually, this is the same as 1/2. It's 1/2 times 1/2, which is where the 1/4 comes from. Okay, it was an even number, not just a single number.
Okay, yeah.
Lucas.
Number 19, I got 1.2.
Is that right? Tell me how you did that.
I added 0.8 to.
Well, that was your first mistake. This was already, if it doesn't have a minus sign in front of it, you need, if you add 0.8 to 0.8, Lucas, it doesn't go away.
Go to 0.2.
But you can't put those together because they're not like terms. You can't put a term that has an x with a term that doesn't have an x. What you need to do is get rid of this altogether by subtracting it to the other side. So you subtract 0.8 from 0.12 and you get 0.4. And now it's 0.2x equals 0.4, so you divide by 0.2. And 0.2 goes into 0.4 times 2
Can you
times.
explain me 15 again?
Hands that are raised, Jackson.
For number 9, I got 1/2 because I just did how many numbers on the number cube and then heads and tails. And I got 1.
You did how many numbers are on a number cube?
Yeah, there's 6, and then I did heads and tails, which would be 8.
No.
And then I did even numbers and a head, and I got 4 out of 8.
Sure, if you want to do it that way, I suppose would work, but you might want to be careful with that.
So that's not correct.
Oh, no, I thought you said, then you can't do it that way. It's multiplication. Anytime it's the probability of getting two different things, you need to multiply those two probabilities together. Probability of getting a head and the probability of getting an even number. The other way to Jackson to do it, if you really whatever, you can write down all your possible combinations and see how many of them you get. But I wouldn't recommend that. You can either flip a head or a tail, right? So you can get a head 1, a head 2, a head 3, a head 4, a head 5, and a head 6, correct?
Yes.
Or you can get a tail 1, tail 2, tail 3, tail 4, tail 5, and a tail 6. How many different combinations do I have here? 6 there and 6 there, correct? That's 12. How many of them would be a head with an even number? Well, here's a head with an even number. There's a head with an even number. There's a head with an even number. That's your only possible choices. So there's only 3 out of a possible 12, which gives you 1/4. But again, it's much easier if you just take the probability of flipping a head, which is 1/2, times the other half for the other one.
Okay, listen.
It's kind of the long way around if you're going to do the long way there. Have a Christ.
For number 13, I know how to change that close to decimal, but not to a percent.
Didn't we already do that?
Yeah, but I'm not.
Well, the gist was, you got the decimal right, you just move the decimal 2 places here. But like I said, the issue with this is we don't like to mix repeating decimals and percents. So you just need to know that, and again, this is on your sheet. What is 0.6 repeater on your sheet as a fraction? It's 2/3. Okay, so that's where the 2/3 came from. And that's usually a more acceptable way because it's just easier to understand there. Wow, suddenly, Nathaniel Lick.
Can you please explain to me number 4? I had the decimals, I had all the numbers right, I just got the decimal wrong.
Well, first of all, what is 7.5% tax as a decimal? And this would be good to write down. 7.5% as a decimal is 0.07, that's 7%. And then half of the next one would be 5. Did you multiply by 0.075?
No, I didn't.
Just like, what would you, let me just throw this at you, what would 7 3/4% be as a decimal? Well, it's 0.07. How do you write 3/4 as a decimal? Another 7/5. So you just tack on the end whatever the decimal would. Do I still need to do this? You're just going to multiply this times this. I still need to do it?
No.
Yeah.
Number is, 15, can you please explain it to me?
I think we did 15, didn't we? I'm not going to re-explain it yet. I did a question on it. Why didn't you ask me? Yeah, I already did that one. Remember I said who made this mistake? Some people raised their hands, some people didn't. Sage?
Can you do number 5? Because I got 128. Mr. Hahn, doesn't something to the 0 power equal 0?
Jack, you missed my whole speech, my friend. D equals 1, sir. Number 5 says the speedometer on Maury's car shows her speed in both miles per hour and kilometers per hour using 1.6 kilometers as an equivalent for 1 mile. Find the miles per hour rate that is equivalent to 80 kilometers per hour. Okay, so who asked me this? Sage? Okay, the gist of this is this. It tells you the conversion rate, 1.6 kilometers, 1.6 km equals 1 mile. That's your unit multiplier, that's your conversion fraction rate, ratio, whatever you want to call it there. So you are asked, Sage, or whoever asked me this thing here, you are asked to convert, you need to change 80 kilometers per hour into miles per hour. So you need to multiply it by the unit multiplier that'll make kilometers cross off, so that tells you what, Sage? In order to get kilometers to cross off, what has to happen?
Has to be an hour.
Well, kilometers has to be on the bottom. But you're not hours, you're talking about miles. So what is our ratio? It's 1.6 kilometers equals 1 mile. Now when I do this, my labels cross off like I want them to. What's that? Is it not right?
I don't know, I just.
Now I need to take, so it's 80 over 1.6. I need to divide 1.6 into 80. So 80 divided by 1.6 is the same as 16 into 800, and you end up with 50. Your answer is 50 miles per hour. Again, unit multipliers. Was that the answer? That's why the speed limit is like 100 miles an hour in Canada, because that's only like 65 miles an hour here. Or 100 kilometers per hour, which seems like a lot. Whew. Nikki Kala.
For number 18, I'm confused on why it would be 10 to the negative 6 power.
Now let's see if we can clear up the monkey water of this one. Number 18, you're confused. Oh, here, I'm surprised this question didn't come up. How do you multiply scientific notation together, Corinne?
Well, you multiply 4 times 3.
Exactly. You multiply the two left numbers together, you get your new left number, which is 12,
And then you do
times 10. And then what do I do when I multiply these two things together? You add exponents together. What is a negative 4 plus a negative 3? Negative 7. Now the issue with this, Jack, you with me, is that this is not in scientific notation anymore, and you need to make it in scientific notation. So you need to take the decimal in 12, move it back a place, so this is now 1.2, and here's what we talked about before. If you move that decimal and change this, that means this exponent's going to change, and you have to think about balancing it out. If I make this number 1 smaller, I need to make this 1 bigger, and a negative 7 plus 1 is a negative 6. So make sure the note I write to myself on problem 18 is say make sure answers in scientific notation. If I make it smaller, exponent gets bigger. If this gets bigger, exponent gets smaller. Vice versa and versa versa. And Lich.
Can you please do number 17 for me?
I'm running out of breath, but I will. Alright, Nathaniel, what you gotta know here is what? How do I deal with a negative 1 exponent?
You put the fractions, add it as positive.
Right. Well, you don't add it, it just becomes, you flip the second one, it's still minus, but it's minus 2/3 instead of that. And since anything to the 1 power is itself, it's just going to be this problem here. What is 3/2 minus 2/3? Common denominator of 6. This times 2, that times 2, this times 3, that times 3. 9/6 minus 4/6 is 5/6. Got time for 1 or 2 more, by the way. If you want to review this again tonight, it will be on WW. Just confusing. And it works. works too, so. I'll put it under, I can't really put it under pretest. I have to list the lesson to put it under, so I would put it under probably lesson number 70. So look for that, it's the last thing on the list. Be fun and exciting. You'd say, hey, I remember saying that. Jack, you can go back to that problem where you asked me that I already did. Nikki Scala, what do you got?
I'm confused on number 11. Like back to the whole parallelogram.
What is the area of triangle ABC?
Yeah.
Okay, well, triangle ABC. Here's the deal with this, and that's a good question because I can see how you'd be confused. Here's triangle ABC, and again, the area of a triangle is 1/2 base times height. And there's that base and height again. They have to form square corners, and if you look, none of these corners are square. But you could take this line and slide it straight all the way over. It's going to be the same line with the same dimension there. It's this 7 with this 10. Okay? This is still perpendicular to that base line, and it would still end up going all the way up to that point, which is there. So it's still going to, you're still going to use this 7 and this 10 for that. And it's 1/2 of 7 times 10, which is half of 70, and that would be 35 inches squared. Mr. Nathaniel Lick.
Okay, I don't understand 20 either.
Right, how is that like almost one of the last ones you got left?
Yes.
Then you said I don't get 20. 20 is really the same thing as that last problem here. You got to get the x by itself. We call that isolating the x. What do I got to get rid of, Nathaniel? Well, I got to get rid of the 3/4. The last thing you deal with is the term that has the x. See, now in this other one, they were mixed up a little bit, and the x term was here. But it doesn't matter. You can flip-flop these and put them wherever you want. You need to get, this is the last thing you deal with, this is the last thing you deal with. Subtract 3/4. If you subtract 3/4, that's 6/8. Let's just do that because we don't have much time left. So I'm left with 3/8 when I subtract those two. Now it's 7/8 x equals 3/8. How do I get rid of a fraction in front of a letter? I just, Corinne, flip a multiply. This becomes 8/7. These all cross off. You're left with 3/7 as your answer. You are left with 3/7 as your answer.
I don't get how you got the 7.
What?
I don't get how you got the 7.
I had 7/8 here.
Okay.
I flipped and multiplied by its reciprocal. That's 8/7.
Oh.
I multiplied 8/7 and 8's a cross cancel. Just 8/7.
Oh, okay.
Again, this will be shown at www. Just confusing. Speak and you shall be heard.